Well, let's get started. Hi, everyone. My name is Ashwin Kumar, and I'm a product manager here at Tableau on the Maps team. I've been on the team for a little bit over 2 years now, been a Tableau user for 4 years, and this is my 4th Tableau conference. Before getting started, I'd like to get to know you guys just a little bit more. Put your hands up right now if this is your first TC. Awesome, wow. Well, all you new folks, welcome. I'm so glad to have you here this week with us. This is supposed to be the best TC yet, so I'm excited that you're here. If this is your second TC, put your hands up. Third? Fourth or more? All right, so judging by that, it looks like we have a pretty good mix of folks in the room here. So even though the session today is called a beginner's guide to maps, it really is something for everybody. So if you're a beginner with Tableau, beginner with maps, today you'll learn the basics of how to use maps in Tableau, how maps work, and some basic dashboards that you can hopefully use back at home. And if you're a veteran with Tableau, today's session is also great for you to refresh your memory on how maps work, and maybe you learn something new. Let's go ahead and get started. So here on the Maps team, we believe in a certain thing when it comes to BI and GIS, or Geographic Information Systems. Because traditionally, BI has been separated from GIS. For example, if you're an analyst and you had a mapping-related question, you might go to your GIS team for that question, and your BI team for everything else. But we believe that everyone, right, even those who might not have a deep mapping background, should be able to ask and answer their own questions start with the word where. So in Tableau, when we build our mapping features into the product, they're meant to work seamlessly across the rest of Tableau, so that everyone, right, not just those who have deeply technical mapping backgrounds, can answer their questions that have to do with mapping data and the word where. So this is Tableau Desktop. This is the screen that you see when you first open up the product. And of course, when it comes to visualizing and analyzing your data, one of the most important things to have is, well, your data, right? And Tableau can connect to many different kinds of data. And when it comes to mapping data, it's really no different. If I were to zoom in here, we can see that we can actually connect to a Microsoft Excel file that might have mapping data in the form of a lat long or a place name. I can connect to a spatial file, like an Esri shapefile, an Esri file geodatabase, or many other common spatial file formats. I can even connect to data in the cloud, such as Microsoft SQL Server Spatial, Postgres, or PostGIS. Really, the name of the game here is wherever your data is stored and however it is stored, Tableau wants to connect to it. But just to kick it off, we'll keep it simple, and we'll connect to a Microsoft Excel spreadsheet. So we'll hit Microsoft Excel, go to my desktop, and look for the superstore.xlsx file, and hit open. And we'll pull that one in. So the great thing about Superstore as a place to begin is actually that all of you have access to the exact same data set that we're going to walk through here. So what that means is after today's presentation, you can go home, or maybe if you're watching this on YouTube 5 months from now, you can actually do the exact same analysis at home on your own. Now for Superstore, let's all put on our analyst hats for just 1 second. And imagine that we're all analysts working at a nationwide department store chain, and we sell goods to all lower 48 contiguous United States. And we have some pretty basic questions we want to answer with our data. Questions like, where are we selling our products? And where are we more or less profitable? Let's explore those questions. Now the first thing that I like to do when I pop open a brand new data set in Tableau is to explore the data here in the data preview page. So we can see here we have a ton of data about our customers and their orders. So each row here represents one different order, and it has an order ID, an order date, a ship mode, some customer information. Going to the right a little bit, we have some location information like country, city, state, and postal code where the order took place. Going a bit more to the right, we have information about the product that was purchased. And then finally, at the far right there, we have information about sales, quantity ordered, any discount that may have been applied, as well as an overall profit for that particular order. So now that we're all familiar with the data set, let's hop into Tableau, the authoring mode. To do that, we'll go to the bottom left-hand corner, where it says Intro to Tableau, and click that sheet. So this is Tableau, the blank slate, the blank canvas. You'll notice on the far left side of the screen, in the data pane, where it says dimensions and measures, all of the different data fields that we just explored in the previous screen are listed here, and broken apart into dimensions and measures. Now dimensions are those categorical fields, things that are categorized, and measures are quantitative fields, things that you can count. And one thing I want to point out here as well is if we were to zoom in just a little bit, you'll notice that each category actually has a small icon next to it. And that icon shows us what type of data is stored in that column. For example, category here is a string field, or a bunch of words. City has a globe icon showing us that it's a geographic role. And order date has a calendar icon showing us that it's a date time field. But of course, this is a mapping focused talk, so let's drill into that geographic role. We'll click on the globe icon next to city and go to geographic role. And here we can see that not only has Tableau automatically identified city as a geographic role, but it also knows that city is actually a city. And it's done the same thing for country, state, and postcode. Now, why is that important? Well, it becomes important when it comes to a concept called geocoding, which we'll get to in just a few minutes. But suffice to say for now that Tableau can do this kind of automatic role detection for any one of these. Are we still getting an echo now? Testing. Looks good? All right, let's keep going. So Tableau does this automatic role detection for any one of these 10 different fields you see here in this list in 11 different product languages. Now, making a map in Tableau is meant to be really, really easy. All we got to do is take any one of our location-driven fields, so in this case, country, and drag that onto the view. And boom, Tableau makes a map. It's just that simple. Now, one of the cool things when it comes to maps is that maps have this sort of natural hierarchy to them, right? We have countries at the top, broken apart into states. States contain cities, and cities have postal codes. And oftentimes in Tableau, users want to be able to drill up and down across these hierarchies. So how do we do that here? Well, to make a hierarchy, I'll go ahead and hold the command button on my Mac or control on PC, and I'll select all the different fields that I want related in my hierarchy. So here I'll click city, country, postal code, and state in that top left corner. And I'll right click on state. Go to hierarchy, create hierarchy. I'll give it a name. In this case, we'll just call it hierarchy and hit OK. So now we can see that we've categorized all 4 geographic roles in the same hierarchy. But there's a problem, right? The order is not correct. Let's fix that. Again, country goes at the top. So let's drag that up. Then state. And then city and postal code look good to me. Now, some of you with sharp eyes may have noticed that when I made that hierarchy, a small plus button appeared next to country here in the marks card. Let's click on that. Now, drilling down from country to state produces 1 mark for each state in the United States. But actually, something really subtle yet powerful happened there. Did you guys catch that? Let's do it again. I'll drill back out to country and back down to state. So the thing is, with this map, is how did Tableau know where to draw each of these points for the United States or for each state in the US? Or if I go to the marks chart and make it a filled map, how does Tableau know what the shape of each state looks like? Right, because if you recall, in our data set, all we had was the name of the place that we wanted to see on the map. We didn't have any information about latitude, longitudes, or what each state looks like. Well, that's because of our built-in geocoding database. Think of it like this. Essentially, on the back end of Tableau, there is this massive geocoding table that contains place names and their synonyms and maps them to latitude, longitudes on the globe, as well as a boundary where applicable. So for example, California is a state, it has an area, so it might have a boundary. Whereas Las Vegas is a city, we don't typically think of those as having areas, so there's no area for Las Vegas. And this is really powerful, because then when it comes to us making a map, we don't actually have to have any specific information about where each item is or what it looks like. Instead, we can just put in the place name, and Tableau does the heavy lifting. So going back to a point map for a sec, let's get some data on this view. I don't know, let's take profit and put that onto label in the marks card. So what we've got now is profit on our map visualized. So we're done, right? All good? Who here thinks this is a great map? Well, you guys are right? I think this is not a great map, not even a good map. In fact, I would say this is kind of a bad map because it's really hard to understand, right? For example, what is the least profitable state in the US? Put your hands up when you got it. I'll wait. Who here said Texas? You see how a few of us said Texas? And Texas is the right answer, right? It's got negative $25,729 of profit, which is really bad. It's the smallest number here, but very few of us got that, right? That's because this map has a lot of data points on it, and we have negative and positive numbers, which are really hard to see with labels. So rather than use a label, how about something else? How about color? Doing that is, again, really easy. We'll take profit in the marks card and put that onto color. And again, here Tableau has some built-in smarts to make the right kind of map to better assist us in understanding the data. If you look in the top right-hand corner of the screen, you'll see a small color legend there that shows us that darker orange or brighter orange is less profitable and darker blue is more profitable. So immediately on this map, we can see Texas jumps out as the least profitable state in the US, and California and New York are the most profitable states in the US. Now there's actually one more problem with this map. If we look very closely on the East Coast, we'll actually notice that there's no data here for Delaware. But I told you earlier that we actually sell our products in all lower 48 states. And I promise you I wasn't lying, so what's going on here? Well, if you look in the bottom right-hand corner of the screen, we'll notice that there's a small unknown indicator here. Let's click on that. So clicking on that brings up the special values dialog. And hitting edit locations allows us to see what the problem might be. Now in this case, it looks like we've actually misspelled Delaware in our data set. We spelled it Delaware. Now ordinarily, I might have to go back to my data source and make the updates there if I can even access the data source. Or I might have to go to my data steward and say, hey, there's a problem, please fix the data. But we don't have time for that, right? We want to analyze our data now. So how do we fix our data now? To do that, we'll just hit unrecognized and type in the right name of the place that we want to see in our data. So in this case, I will spell it correctly, Delaware, and hit OK. So now we can see immediately, Tableau recognizes that Delaware is Delaware and puts the data in the right spot. Now keep in mind, what I just did right here doesn't write back to the data source itself, so you still have to get someone to do that manually on that side of the house. But in this case, we're now unblocked and we can proceed with our work. Now, in addition to seeing profit numbers on the map, we might also want to see other measures on our map. For example, quantity of goods sold. And we can do that using different types of mark types. For example, I can go down to the bottom left-hand side of the screen where it says quantity and drag that pill into the marks card on size. And I'll make those marks just a bit bigger so we can all see them. I'll click on size in the marks card and just pull that slider up. So now we can see a map that shows each mark color-coded by the amount of profit or loss that we're making, as well as sized by the amount of quantity goods sold in each state. So now we can see information like, okay, in California, New York, we're selling a lot and we're very profitable, so maybe we'll invest more in those states. And in Texas, we're very unprofitable, we're still selling a lot, so clearly there's some issue there, and quantity of goods sold is not the problem. Now, given that we all have access to the data set, I'll leave it as an assignment to you to go home and figure out what's going on with this data set. Actually, the first 5 people to email me afterwards with an answer as to why Texas is so unprofitable, I'll send you a Starbucks gift card, so get on that. But for now, we'll actually go ahead and move on to the next example. So I actually probably spent a little bit too much time on the internet browsing memes. And one meme I saw this summer go viral on Facebook was this event right here. It was called Storm Area 51, They Can't Possibly Stop All of Us. I'm just curious, was anyone here in the crowd at this event? It's okay if you were. My hand's raised. I wasn't there, I promise. But actually, apparently more than 1,500 people actually went to this event. So if you were there, find me afterwards and we'll talk about it. And fun fact, that's actually bigger than the very first TC. So I would say it was a successful event. Now, while I didn't actually go to the event, it did pique my interest, and I realized that I wanted to know more about UFO sightings in the United States. So I went ahead and downloaded a data set that has information about UFO sightings in the United States, and I wanted to analyze that in Tableau. Let's go ahead and do that. So we'll go to the top left corner of the screen and click the Tableau logo up here. Clicking on that goes back to the Connect to Data page. And in this case, I happen to know that the UFO data set is, again, another Microsoft Excel spreadsheet. So I'll click Excel, and I'll navigate to the UFO sighting spreadsheet and click Open. So again, now we've got this data preview window where we can explore our data set before getting it into Tableau, the authoring mode. So here we've got some information about a summary of the sighting. We've got the country, state, and city of the sighting, the date and time at which the sighting occurred, the shape that was seen in the sky, as well as the duration in seconds of the overall event. Let's go back into Tableau. So here in the bottom left corner of the screen, I'll click the UFO map. So again, making a map in Tableau is meant to be really simple. Just drag the location field onto the view. So here I'll take country, put it on the view. And now we can see one mark drawn for Canada at the top of the screen, and one mark drawn for the United States in the bottom of the screen. Now in our case, I really want to focus in on the United States, so I'll go ahead and select that mark for Canada and click Exclude. So this hides all Canadian marks from my data set. I'll go back into that marks card and drill down from country to state in my hierarchy. And we can see that we have sightings of UFOs in all 50 US states. Now for me, in this case, I again want to focus just on that contiguous US, so I'll go ahead and select Alaska and Hawaii and exclude them as well. Now you might notice that as I do this, the map is actually shifting its focus, right? And that's because Tableau wants to keep our data that we care about in the center of the view. And we can turn that off if we wanted to, but in this case, I kind of like it. We'll drill down one more time from state to city. And now we can see one mark drawn for every state, or for every city where we had a UFO sighting. Now, again, those of you with sharp eyes might have noticed in the bottom right-hand corner of the screen, we have a little indicator that says 34 unknowns. What's happening there? Let's click on that and find out. Again, bringing up the special values dialog and hitting edit locations, we can see that we have a bunch of unrecognized cities and towns. So what's happening here? Well, basically, Tableau remember how Tableau has this built-in geocoding database that does all the geocoding right here in my machine, right here in my secure area? Well, one downside of that is Tableau has a limitation on how much data we can store in that database, so it doesn't get too big and too slow. So in this case, I guess depending on the role you're looking at and the part of the world you're looking at, the coverage varies. But for the United States, when it comes to cities and towns, the limitation is at about 1,000 people or so, our coverage gets a little bit iffy. So in this case, if I wanted to see Elk and Dallardsville on my map, I would have to get my own latitude, longitude coordinates and plug that in, but I'm not going to do that here. So I'll just click Cancel. So going back to the map view here, we can see that we have a ton of dense data. And it's really hard to tell any patterns from this view right here. But luckily for us, Tableau has a built-in density mark type that allows you to see patterns from dense data like this. Going to the marks card and hitting the dropdown, we can see the appropriately named density option. Let's click on that. And just like that, Tableau produces a density heat map that shows us that Southern California and the Northeast have a density of UFO sightings in our data set. Now I can even do more things, like customize the colors that are used in this heat map. For example, in this case, blue does not remind me a lot of aliens. I prefer green for aliens, so let's fix that. We'll click Color in the marks card, hit the dropdown for the color dropdown, and choose Density Green Dark. All right, that's a little bit better, right? Now we'll go to the intensity slider and bring that over just a little bit so that our dense areas pop a little bit more. Now, so far, we focused just on the foreground of the map, just on the data that we bring in to visualize on top of a map. But we've so far completely ignored the background of the map, which is almost as important, for two primary reasons. Right, number one, when it comes to the background map, that allows us as dashboard authors to give our viewers or consumers more context to understand our visualization. For example, here, we might all be familiar with the United States at this level. So in this case, the background map is probably good at that level. But imagine if we were looking at a small suburb in California, or a random countryside in Germany, or a random part of the island in Japan. We're not all familiar. In that case, we might want to customize that background map to give additional features to allow our users to better understand what the map is showing. Now, the second most important use case for a background map is aesthetics, right? That way the map just looks better. So in this case, I'm not a huge fan of this light gray background with my green heat map, so let's fix that. We'll go to the top of the screen and click Map, Map Layers. Now on the left-hand side of the screen, you'll see the Map Layers pane has appeared. And this is where we go in Tableau to customize that background map. For example, at the top of the screen, we can see a Style drop-down menu. Clicking on that reveals 6 built-in Tableau background map styles. These are available for use on an unlimited basis directly out of the box. Light, normal, and dark at the top of the menu are best for those general data visualization use cases, and streets, outdoors, and satellite are each best for their own specific use cases. For now, though, let's focus on just those top 3. So clicking normal, we can see that the color scheme of the background map has changed just a little bit. It looks okay, but I want to keep going. How about dark? I don't know about you guys, but this looks pretty cool to me. So I want to stick with the dark map style for this specific visualization. Now, besides the background map color, we can also change several other aspects of the map. For example, the next option down is the washout. I can go ahead and pull that slider across, and we can see how the background map slowly fades out from view. However, here, I think it's best at 0%, so I'll bring it back to 0. We can also adjust the repetition of the background of the map. What does that mean? Well, if I zoom out on my map, I can see that the map actually has borders on either side. Clicking repeat background causes the background to repeat. Now, in addition to those settings, we can also toggle the background map layers that are present directly in the view. That's done with these map layer toggle checkboxes. So for example, if you keep your eyes on a state label in the map, I can turn those off by just clicking the correct box. I can turn off state borders, country names. Everything you see in the left-hand side checkbox can be turned on and off. But here, I think we want all those things on, so I'll put them back on. Now finally, going to the bottom part of the map layers pane, we'll see an area called data layer. Clicking that dropdown, we can see that we have up to 20 different demographic data indicators coming directly from the US ACS census. And these are really useful in certain use cases. For example, I can see household size on average aggregated by state. I can even drill down from state to county to zip code to census tract. Of course, in this case with UFOs, perhaps that's less valuable, so let's go ahead and turn those things off. Now there's so much that we could do with this data set here. And if we had a bit more time, we might end up with a view that looks kind of like this. Now, one of the most amazing parts of this view here is that the entire dashboard is interconnected. For example, we have a bar chart that shows UFO sightings over time. We have a label that shows how many sightings occurred in our selection, as well as a heat map that shows the UFO sightings in our selection. Now, what I can do here is actually click on different bars in the bar chart. And I can watch the other 2 aspects of the dashboard update in response to that. For example, I can see here in the year 2012, we had over 7,000 reported UFO sightings, and they were kind of evenly distributed across the United States. However, I went to 1995 and clicked that bar. We had almost 1,400 sightings, and they were clustered somewhere up near Seattle. So now we can see more patterns sliced across time. So far, we've connected 2 data sets that had Microsoft Excel as their data sources. But what about other spatial or mapping data sources? For example, spatial files, right? Let's check out an example with spatial files. So again, clicking the top left corner, the logo, we'll go back to the Connect to Data screen. Now, prior to living in Seattle to work at Tableau, I actually lived in the SF Bay Area. And one of the things I noticed in San Francisco as time went on is that crime seemed to get more and more rampant in the city. So I figured, okay, how about we analyze crime in San Francisco to see if we can find any patterns throughout how crime is spread across police districts in the city. So perhaps if I were ever to move back to the Bay Area, I might know where I do and don't want to live. Let's go ahead and connect to a spatial file that contains information about police districts in the city of San Francisco. We'll click Spatial File and go to our SF Police Districts Esri shapefile. Now, not all of us might know what a shapefile is, and that's okay, because the whole point of what we're trying to do on the Maps team is make it so that you don't have to know what a shapefile is to use spatial data. All you have to know is that a shapefile contains some sort of custom mapping information that I can visualize in Tableau on a map via simple click, drag, and drop. So for example, in this shapefile, we can see all the data that's contained within. We have the name of the police district. We have some area and perimeter information, as well as a column called geometry. Now the way geometry works is kind of a mystery, but all we got to know is that this is our mapping location field, as denoted by this small globe icon. So going to the police districts worksheet, let's again make a map. We'll go ahead and drag that location field directly onto the view. And just like that, Tableau knows how to render spatial files on a map in Tableau. We didn't have to know anything else about how it works. Now, if I were to hover over these polygons here, we can see that we actually are selecting all of them at once. And that's because, by default, Tableau aggregates all of our marks into one. So let's go ahead and break those apart with a unique identifier. In this case, we'll take the district name from the top left corner of the screen and put that onto detail in the marks card. So this allows us to disaggregate all of our marks in the map. So now we can hover over Taraval and Park and the northern districts independently. So great, we got our police districts into Tableau, but what about crimes, right? Because I wanted to study crimes across the city of San Francisco. So let's connect to that data set. We'll go to a new worksheet here called Individual Crimes and go back to the Connect to Data page. Now in this case, I happen to know that the crimes data set is contained within another Excel spreadsheet. Let's bring that in. We'll click Excel and find our data set. So here it's called sfcrimes.xlsx and hit open. So just like before, in this preview pane, we can see all the information contained within the data set. So here we've got information about the date and time of the crime. We've got the year that it occurred, the day of the week. We've got our unique identifier called incident ID. We've got a category of the event, whether it was an assault or a robbery, a larceny theft, or something else, as well as information about the police district in which the crime occurred, and the latitude, longitude coordinates of that crime. Now keep in mind, this police district column right here is not the same as what we just saw in the shapefile. This column here is just a string. It's not boundary information. So if I go to my individual crimes worksheet, I can hold the command button on Mac or control on PC and select latitude and longitude in the bottom left corner of the screen in the measures area. I can pull that onto the view. Oop, I think I might have let one go. Let's do that again. So again, just like before, Tableau knows how to draw a latitude-longitude map. Now zooming in on the Bay Area, we can see that there's, again, only one mark. But as we know, certainly more than one crime occurred in the entire city this year, right? Again, all these crimes are being aggregated into one single mark. So let's break them apart with that unique identifier. In this case, it's going to be incident ID. We'll take that, or is it incident number? We'll see. We'll take that, put it on the detail, and boom. Just like that, Tableau has drawn almost 40,000 marks, each one representing a different crime that occurred in SF this year. Now, one of the things that you might have obviously noticed as well is this background map is a bit more colorful than the other ones, right? This is Tableau's built-in streets background map style, which is very similar to Google Maps. So if I were to zoom all the way in on the downtown part of the city and make those marks a little bit smaller so they get out of the way, we can really see how much detail is packed into the streets background map style. For example, we can see that parks are colored green, hospitals are colored red, and elementary and schools are colored in this gold color. And each one of those actually has a label as well, marking it as a point of interest. I can zoom in even further and see that highways and roads have labels and highway shields on them. And going even further down, I can see building footprints appear and even more background information appear of all these points of interest. Things like hotels, restaurants, coffee shops. It's all right there in that background map view. I can even pick out some street addresses right here, which might be useful in certain use cases. And then of course, as with before, if I don't want these layers in my background map view, I can just turn them off. We'll again go to that map layers pane, and just toggle the ones that we want not to appear. For example, I can turn off house numbers, turn off building footprints, even turn off roads if I wanted to, and really make this background map appear exactly how I want it to appear for my viewers. But in this case, I think we want those things to turn back on. So besides streets, we also had the outdoors and satellites background map styles. Let's select those and see what happens. So outdoors looks pretty similar to streets in an urban setting. But if we were to go to a more nature outdoor setting, for example, the Yosemite area, and go all the way into a mountainous terrain, we can see highly detailed topographical contour lines appear in the background map. So this type of map style is very useful for these kind of outdoors use cases. And then finally, switching to our satellite view, Tableau actually has highly detailed 22 zoom levels of satellite imagery directly in the product. So for example, if I were to go to the Bahamas, I can see how crystal blue that water appears. And going all the way in, I can see the white sandy beaches that I might want to visit at the end of this week. Now, perhaps the 6 Tableau background map styles aren't quite what I want. Maybe I want something a bit more custom. Well, Tableau has options for that as well. Going up to the top of the screen and clicking Map, Background Maps, Manage Maps, we can see an area we can add more third-party custom background maps. For example, clicking on the blue Add button, we can see options for WMS, or Web Map Services, or Mapbox. Now, WMS servers are servers that are oftentimes inside enterprise secure environments. So for example, if you have your own on-prem mapping server, you can connect to it via WMS directly in Tableau via a simple copy and paste of a URL. Or if you wanted something a bit more custom, you might use a third-party service called Mapbox. Let me show you. So this is mapbox.com, and Mapbox is a close Tableau partner. And Mapbox is where you can go to make a really highly customized background map style. You can see some of mine listed here. Let's click on North Star and see what's inside. So with the North Star background map style, I've elected to make kind of a more ocean-focused map style. And you can see the shading in the water that shows deeper blue where the water depth is deeper. And I want to see this background map in Tableau. Well, doing that is very simple. We'll go to the top right-hand corner of the screen and click Share. Then in this dialog, we'll click Third Party and select Tableau from the drop-down menu. Then we'll click the blue-purple icon to copy the URL and go back into Tableau. Now here we'll click Add, Mapbox Maps, and we'll give it a name. In this case, I guess we'll call it Mine. And we'll paste in the URL that we just copied and pasted. And hit OK. So just like that, we now have our custom Mapbox style directly in Tableau. And this is amazing, because in Mapbox, I can customize everything about this background map. I can customize all the colors, the layers that appear, the fonts. Everything can be customized, and all the layers can be turned on and off in the left-hand side of the screen, just like any other map in Tableau. OK, now going back to the original point of this exercise, which was to look at crimes in SF. I still have not answered my question, right? I wanted to see which police districts in SF have the most crimes. So essentially, I wanted to see this crime data here somehow joined with my police district boundary data in the other worksheet. But how do I do that? Well, to do that, we can use what's called a spatial join. So going back to the connect to data, to the data source page, so in the bottom left-hand corner of the screen, we can click the data source page. We can see here the SF crimes Excel worksheet already loaded in. Let's add on to that our data set containing boundary information about crimes in SF. To do that, we'll click the blue Add button in the top left corner of the screen and navigate to Spatial File, because if you recall, the boundary data set was a spatial file. And we'll go ahead and load in that same spatial file that we connected to earlier, and click Open. So now we're going to join our Excel file with the shape file. And we'll do that on a common field. In this case, the common field is the police district. So we'll select police district on the left-hand side, do an inner join, and equate that with district from the shape file. So now we can see in the bottom half of the screen, we have now joined together those two data sets. So we have one row representing each different crime in SF, along with, it will join together with the actual boundary itself of that police district. So now going back to the individual crimes worksheet, I can actually clear the worksheet by clicking the delete button in the top of the screen. And, well, where do we go here? So I'm actually not sure where that left-hand side data pane went. So let's go to police districts and do this over again, if it's going to show up for me. You guys know what happened at all? This thing right here? You guys are awesome, thank you. So clearly you're not beginners, right? What are you doing in this session? All right, so where were we? We had joined together data set. Let's do that again. All right, so here we are with the spatial file loaded in, right? So I guess the join didn't take. So in this case, because we have the spatial file loaded in, we'll actually add on the Excel file containing the crimes data into this data set again. So here we'll click Add, go to Microsoft Excel, and load in that crimes data set. And just like before, we'll join on that common police districts field. Boom. Now going to that individual crimes worksheet, looking in the far left-hand side of the screen in the data pane, we can see all of the different data fields in that joined data set appear. So again, just like before, we'll take geometry and put that onto the view to draw that map of police districts in San Francisco. We'll go ahead and disaggregate by pulling police district onto detail. And then finally, we'll take the crime data set, number of records, and put that onto color, because number of records is the number of rows in that joined data set. And for good measure, we'll change the color scheme here just because we can. We'll click Color, hit Edit Colors, go to that dropdown, and choose the orange color scheme. That way it really pops. So now we can see in the top right-hand corner, based on that color legend, the places that have darker orange have more crime. So now, for example, I know that the Central District, the Northern District, and the Mission District have the most reported crimes in SF. But be careful, right? We have just run into one common pitfall when it comes to maps, which is this might actually be just a map of population across SF. For those of you who've been to the city before, you know that this portion of the city, in the top right-hand side, is where more of the people live. So it stands to reason that there's more crime where there are more people. So what I might want to do if I want to go a step further in this direction is actually join in a data set that has population across each police district and do a crime per capita calculation to create a map that shows crime rates across SF. That might be a bit more informative. But in this case, we'll go actually a different direction. I'm interested in seeing the crimes that occur in each district in a bar chart. So for example, let's go to this crime types worksheet and make a bar chart that shows all the crimes that occurred in SF. To that, we'll take incident category and put that onto rows. Then again, we'll take number of records and put that onto columns. And Tableau knows that it should make a bar chart. We'll go ahead and sort this from most to least and change that color scheme to be the same as the other map. So now we can see that by far across SF, the most commonly occurring crime is larceny theft, followed up by some sort of miscellaneous category, assault, and non-criminal and malicious mischief. Okay, that's great, right? But what I really want to see now is what are the most frequently occurring crimes in each police district. And I want that to be fully interactive so that when I publish my view, all of my viewers or consumers can answer their own question with this data set. To do that, we'll make a new dashboard called Crimes by District, and we'll drag on the map and the bar charts that we just created. So let's go ahead and take individual crimes and put that on the top half of the view. And we'll take crime types and put that on the bottom half of the view. Now the goal here is to make it so that if I click on any district in San Francisco, the bottom half of the view updates in response to that click. So in this case, if I clicked on the Terraval district, I want to see a bar chart that shows all the crimes that occurred in that district. Making this kind of cross-dashboard filter action is really simple. We'll go into the top right-hand corner of the screen and click the small filter icon and zoom back out. So now, if I clicked on the central district, for example, that bottom half bar chart reacts in response to that click. So this is what I mean when I say that Tableau maps are designed to work across the rest of the product. They're designed to be fully interactive and dynamic, so you can combine maps with non-map viz types to really make a fully interactive experience. All right, let's cover one more thing here before we head out. So far we've covered how to use the Tableau built-in background map styles. We talked about how to bring in a custom Mapbox style or WMS. And here we have a satellite image view. But what if none of this is really what I want? What if I have a special use case? For example, here in Vegas, if I worked for MGM, I might want to have a casino floor plan that shows where are my most and least profitable slot machines. Or maybe if I worked at a large department store, I might want to have a floor plan of my department store that shows which items are in stock and which ones are out of stock. Or if you're like me and you love traveling, you might want to know in Disneyland, where are the more fun rides and the least fun rides? So let's go ahead and answer that question. So popping over to the Disneyland worksheet, we'll go ahead and connect to the Disneyland sheet that I've loaded in ahead of time. Now this Disneyland worksheet, or the data set I can show you, is a simple Excel file, and it has information about the attraction name, the attraction area, a description of the ride, the cohort of this specific row, the rating that that cohort gave this ride, as well as the XY coordinate of the ride. So what I want to see here is of people in my cohort, whether it's grade school, adults, young adults, teenagers, I want to see how they rated rides in Disneyland so that I know where I can have more fun and less fun. And I want to see that all on a customized map of Disneyland. Let's go ahead and do that. So to load in our custom Disneyland map, we'll go to the top of the screen and click Map, and hit Background Images, and select the data set that we want to apply the image to. In this case, it's Disneyland Rides Final. Now here we'll add in the image, hit Browse, and I happen to know that the image is called disneylandmap.jpg. So we'll open that up, and now we'll assign the X and Y coordinates of the map. Now what exactly is happening here? Well, if you think about how a map works, right? A map is essentially just a coordinate grid. And as far as what exactly the X and Y units are, it really doesn't matter. All that matters is that the X and Y coordinates, the units that I use, are common across my map and my data set itself. So if you recall from that data source that we viewed earlier, my Disneyland rides had XY coordinates that had values that ranged about from 0 to 10. Right? We saw the one that had the X as 4 and the Y value is 6. So all my XY coordinates are from 0 to 10. So we'll plug in those values here. So the X field ranges from 0 to 10, and the Y field ranges from 0 to 10. Then we'll go up to the Options menu and make the image always show, and hit OK. Actually, we'll make the washout a little bit more as well because I can see that this image here is super vibrant. We'll go back out and hit OK. Now the next step that we want to do is go back to the top of the screen in the map menu and tell Tableau not to use the built-in Tableau map. We can do that by clicking the None option. So now we're ready to make our map. We'll go ahead and pull the X value and put that onto columns. Then we'll take the Y value and put that onto rows. And boom, just like that, our Disneyland map now appears in that background map view. I can make that mark type a bit more visible by changing it from automatic to a circle. And now you can see one mark appear almost in the middle of our view. Why is that one mark there? Well, again, just like before, Tableau automatically aggregates all of our marks into one. So let's break them apart with that unique identifier. In this case, the identifier is the attraction name. So going to the top left corner of the screen, we'll pull attraction name onto detail. And now we can see one mark appear for every single ride in Disneyland. I'll make that a little bit smaller so it looks a bit better. Now, what we might not want to have is those X and Y axes, right? So let's hide those. We can just right-click on the axis and uncheck the Show Header button. We'll do the same thing for the X-axis. So now we have a map that shows all the different rides in Disneyland. But if you recall, my question was, how do the ratings of the rides vary among different cohorts or age groups of Disneyland visitors? To explore that, we can pull rating onto color and adjust the color scheme to be a bit more visible. So in this case, I'll click Color in the Marks card, and hit Edit Colors, and change that drop-down to something a bit more visible. In this case, I will choose the gold and purple diverging color palette. And hit OK. But be careful, right? Because one thing has happened here. Tableau has actually summed up all the different ratings in the data set. But we actually want an average. So we'll go ahead and hit the drop-down and change the aggregation to average. Then the other thing that's going on here is we're actually averaging the ratings of all of our visitors to Disneyland. But the thing is, across our cohorts, we may not have had the same number of visitors in each cohort. For example, we may have had more children than adults visit Disneyland. So to break that apart, we'll take the cohort field from the top left corner of the screen and put that onto filters. And we'll just select all. And we'll hit that drop down in the filter shelf and click the Show Filter option. Now in the top right-hand corner of the screen, you can see all the different cohort options available for use. But in this case, I only want to see one at a time, so I'll hit the drop-down to edit that filter and change it to a single value list. So now I can see here that adults are less of a fan of Mickey's Toontown. They gave Minnie's House a poor 2.3 rating, and they really enjoyed the Millennium Falcon ride in the new Star Wars land, giving it a 4.9 average rating. Now looking at grade school children, on the other hand, they really enjoyed Mickey's Toontown. Go figure, right? And they seem to really not enjoy the Millennium Falcon ride. Maybe it was too scary for them. I don't know. Now, one other way we can go with this visualization is to make a dashboard that looks something like this. Now, there's a lot going on here, so let's break it down. Across the top half of the screen, we have custom icons that are each a different land in Disneyland, Adventureland, Mickey's Toontown, etc. And the coolest thing is these icons are actually buttons that I can use to filter my other parts of the dashboard. So for example, I can click Critter Country and see the ratings of all rides in Critter Country, as well as where they're located on the map. I can do this for any ride in Disneyland. Oh. All right, so to summarize what we've done today, we started off by connecting to location data in a Microsoft Excel spreadsheet. We learned about geographic roles and geocoding, and how hierarchies work in Tableau to drill up and down on a map. And we even looked at shaded map, size maps, and labeled maps. We then studied UFOs and looked at how to build a heat map or density mark type in Tableau, as well as change the background map style, toggle background map layers, and even bring in a connected dashboard for use with a map. Then we looked at crimes in SF and learned how to bring in custom background map styles, as well as use the streets background map style, as well as make a connected dashboard dome connected by a filter action. Then finally at the end, we looked at Disneyland, and we figured out where I might want to go the next time I visit Disneyland. Thank you all so much for your time. That's all I got for you today. If you have any questions, come find me afterwards. If you enjoyed today's session, these are two related sessions you might want to check out. These all build on top of each other as far as getting more out of maps in Tableau. Don't forget to rate the session. It helps us get better for next time. My email's on the screen. Feel free to reach out. Thank you.